And here we go with part 2 of the mole ratio problems. Now in this video, I'm going to teach you how to add on one more step to the mole ratio concept. We've learned how to use the mole ratio to convert from moles of one thing to moles of another. Now we're going to add in our favorite thing, which is the formula mass. As you know, things aren't measured in moles in the lab. You have to convert from moles to grams. All right, so again, we have to start with a balanced equation. So the next 4 problems all are using this balanced equation at the top. And it's already balanced for you, so you don't have to worry about that. Now, here, if you read number 5, let's see here. We start with we start with moles of phosphoric acid, and we want to end up with grams of calcium hydroxide. All right, so let's find those things in our equation. Here's the phosphoric acid. Remember, acids start with the H. And what are we looking for? Calcium hydroxide, this guy right here. We want to know if we react 15 moles of phosphoric acid, how many grams of calcium hydroxide are needed in the reaction. It's a very important skill that you're going to learn here. All right, so as with every mole ratio problem or any mole problem, start with what's given in the problem. So let's go ahead and write that in. 1.5 moles of phosphoric acid, H3PO4. All right, the units do get a little tricky here, so just be consistent. Make sure you include enough of an annotation so you know moles of what, in this case, because we've got moles of 2 different things going on at once. All right, control question mark. So again, we need to cancel out what we start with, and we want the numerator to include what we're trying to find. So we're starting with moles, so we're going to go straight to the mole ratio step. So if you look at the balanced equation, it's 2 moles of H3PO4 to every 3 moles of calcium hydroxide. So we're looking for calcium hydroxide, so I'm going to put that on the top. Okay, OH2. This, I think, let's leave out the parentheses because that gets things confused. All right, and 2 moles of H3PO4. So far, we haven't done anything new. This is exactly what we did in the first set. Started with moles, used the mole ratio, and then we have the moles of the new thing. Now, if you notice, though, that we want to find grams. Now, here's where the subscripts come in. We've used the coefficients in the mole ratio, and then the last step we're going to do is change from grams to moles of the calcium hydroxide. Well, I'm going to click under here so I can figure out the chemical formula, the formula mass. We already know the chemical formula. All right, look on your handy dandy periodic table. Calcium has an atomic mass of 40.1, and there's only one of them in the chemical formula. Oxygen is 16, and we have 2 of those. 2 times 16. Oopsies. And hydrogen is 1.0. We have 2 of those. Okay, so here's where the subscripts come in. We use the subscripts to calculate the formula mass of the substance. All right, so the mass of 1 mole of calcium hydroxide is 74.1. And that's what's going to go in the numerator, because we want ultimately to figure out the number of moles. That's the mass of every 1 mole. And control question mark, and there we have it. Now we need to round to the correct significant figures. Of course, that is based on the original number. 1.5 has 2 significant digits, so we're going to round this to 170. So as a chemist, you would know you have to measure out 170 grams of calcium hydroxide. Simple as that. So just to review what we've done. We started with the number given in the problem. That's the 1.5. And since we started with moles, we go straight to the mole ratio step. The mole ratio step, you use the coefficients from the balanced equation. And so we have, for every 3 moles of calcium hydroxide, we have 2 moles of phosphoric acid. Then the last step is simply changing from moles to grams of the calcium hydroxide. So we totaled up all the atomic masses in the compound for calcium hydroxide, and we put the formula mass over 1 mole. And that's how we got our answer. Now here's where people get confused. Oftentimes people will try to use the coefficient in two places. The coefficients from the balanced equation only go in the mole ratio step, which is here. The formula mass of the substance is only goes here, and that's the mass of 1 mole. All right, enough talking about that one. Let's try the next one. The next question, we want to know the mass of calcium phosphate produced when you react 0.95 moles of calcium hydroxide. Now, don't get confused here. It says with excess phosphoric acid. All that means is that we have way more phosphoric acid than we need. So therefore, we're basing all of our calculations on the calcium hydroxide because that's the known quantity. And then we want to know how much of one of the two products is produced, the calcium phosphate. All right, so just like always, start with what's given in the problem. So we're going to click in here and start with 0.95 moles of calcium hydroxide, CaOH2. That's where we started last time. No, it's not. We ended up with calcium hydroxide. We want to go to the mole ratio step next because we want to know moles of calcium phosphate. All right, so here's what we're looking for, the calcium phosphate. Here's what we start with. So we know for every 1 mole of calcium phosphate, we have to react 3 moles of calcium hydroxide. So that's what's going to go in our mole ratio step. 1 mole of calcium phosphate. And for every 3 moles of calcium hydroxide. Okay. And then our last step is, okay, Ca3PO42. All right. Well, just put those in there, but don't put the parentheses in because then everything gets messed up. All right, control question mark. Our last step, we need to change from grams to moles of the calcium phosphate. Okay, so we're going to go back to the periodic table and total it all up. Well, we know calcium from before. We have 3 calciums in the chemical formula. Each one is 40.1. Phosphorus, I don't know off the top of my head, is 32.1. And we have 2 of those, 2 times 32.1. And oxygen, we have 8 of those. 8 times 16.0. All right, so the grand total is 312.5. That tells us the number of grams per mole for calcium phosphate. So we're going to put that on the top. I'm going to try to be consistent with the way I wrote that unit. That's the mass of every 1 mole of calcium phosphate. Let's see if I got it all right. Yay! It all canceled out and we're left with grams of calcium phosphate. Final step, round to the correct significant digits. Final answer is 99 grams of calcium phosphate. So that's how much of that product will be formed from the chemical reaction. Again, I will give you a quick review. We started with the number in the problem, 0.95 moles of calcium hydroxide. Since we started with moles, we go straight to the mole ratio step. We use the coefficients in the balanced equation, 1 mole of calcium phosphate for every 3 moles of calcium hydroxide. Then the last step, the one we're most familiar with, is the formula mass. So I, down here, total up all the atomic masses in the calcium phosphate, and then I use that in the final step to change from grams to moles. So then grams on top is the formula mass of calcium phosphate, and that's the mass of 1 mole. So that's why I have 1 mole underneath. And then round to correct significant digits, and you're done. Okay, there's 2 more using that same equation and using the 2 steps. So I want you to give it a try and check your answers at the bottom. When you're done with these, you'll be ready for the 3rd installment of the mole ratio problems videos.